Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, here's step 2, here's step 3, and your challenge is to figure out how many bricks are in step 4. This is a tough one. If you can figure out that, can you figure out how many in step 43? And could you write an equation that could be used to express the number of bricks in any step at all? That's the challenge today. If you'd like to accept it, pause the video and see how far you can get. Okay, so I think this one is really difficult. We've got this sort of swirling pattern of bricks, and it looks like, let's see, there's this inner layer and then an outer layer. So 2 layers there, and then 1, 2, 3 layers on the next one, and 1, 2, 3, 4 layers on the next one. Okay, so it looks like we're adding a layer each time. That will help us sort this out. Let's see if we can count how many bricks are in each layer then. So first it's 4 on this very inner one, and then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 4 and 8. I'm actually going to start making the chart of the numbers here because we're definitely going to need to analyze these. So I'll make the step number and the number of bricks. So in step 1, we've got 4 plus 8, that's 12. And then here's our 4 plus 8, so there's 12 already. And then the next layer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Aha, so that doubles from step 1 to step 2. This 12 plus 12 is 24. How about step 3? So there's our 1 layer, second layer, third layer, and then we add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So adding 16 to that would give us, would give us 40. Now let's see if we can predict step 4, because we're going to add one more layer of bricks, and it looks like on a side there's 2 bricks in the outer one, and then 3 bricks, and then 4 bricks. So I think we're going to have 5, 5, 5, 5 wrapped around the outside of that 40. So that would be 40 plus 4 times 5 is 20. That would be 60 altogether. So that's my prediction for step number 4. Now let's take a look at these numbers. Let's analyze them by finding the difference between each step. 24 minus 12 is 12. 40 minus 24 is 16, and 60 minus 40 is 20. So not a constant, but I didn't expect this to be a linear pattern. It seems like it's growing much too rapidly for that. Let's find the difference of the differences. So 16 minus 12 is 4, and 20 minus 16 is 4. So we do get a constant there in the second order differences, which means it's a quadratic. So there's an x squared involved somewhere. And actually, because this number is 4, we divide that in half to get the coefficient of that x squared term. So 2x squared is going to be in our equation. In fact, that's going to be the leading term of our equation. But what the rest of it is, I think is extremely difficult to sort out. I think the way I'm going to approach this is actually to look at the numbers. And what I'm going to try to do is make a chart again with those 4 steps. And I'm going to try to break these numbers down into 2 of the biggest squares that I can find in there, and then whatever's left over. So in 12, well, there's definitely 2 1 squareds, but I think there's 2 2 squareds we can fit in there, but 2 3 squared, 2 9s wouldn't fit. So a 2 squared is a 4 and a 4, and that would leave a 4 left over. Let's try this pattern with the next one. If we have a 2 3 squareds in here, so a 9 and a 9, what would that leave over? That's 18. 24 minus 18 would be 6. Okay, what we're hoping for is to see a pattern in these leftover numbers, because this pattern we're kind of imposing. Let's look at the third step. Let's go up the next square. So this is 2 squared, 3 squared. This would be 4 squared. So 16 plus 16, those would both fit in 40. And that adds up to 32, leaving 8 over. Oh, this is looking promising. And let's try it with number 4. We can definitely fit 2 5 squareds in there. 25 and 25 would be 50, and that would leave over 10. And look at what's left over. It goes up in a regular fashion, 4, 6, 8, 10. So now let's think of these numbers as 2 squared and 2 squared here. So this is step 1, but we've got 2 squared. So this would be 1 greater than the step number that we're squaring. So x plus 1 quantity squared would represent a single 2 squared. And then we've got 2 of them added together, or I could just multiply that by 2. So that's this chunk. And that should work for each of these chunks. In step 2, 2 plus 1 would be 3, squared would be 9, and then 2 of them 9 plus 9, etc. But how about this 4, 6, 8, 10? How do we get that? Well, when something's changing by 2, we know we're going to multiply it by 2. And so when I say it, I mean the step number. So we're going to take 2 times the step number and then see how that gets us to 4. So 1, when the step number is 1, 2 times 1 would be 2. So I'd be 2 short of 4. So I'd add 2 there. So I think that's the expression for this number. Let's make sure it works with number 2. If I put step number 2 in here, it'd be 2 times 3 plus, 2 times 2 plus 2. That'd be 4 plus 2 is 6. How about 3? 2 times 3 plus 2, that'd be 6 plus 2 is 8. Yeah, so this expression seems to be working to predict this part. So this part is this chunk, and then plus 2x plus 2. So this is our equation. I'm actually going to FOIL that out and simplify a little bit. So the x plus 1 squared would end up being x squared plus 2x plus 1. And I've still got my plus 2x plus 2. I'm going to distribute that 2, so I'd get 2x squared plus 4x plus 2, and then plus another 2x plus 2. And I'm getting 2x squared plus 6x, combining those like terms, plus 4. So this, I think, is our equation. If I plugged in 1 here, I'd get 2 plus 6 plus 4. So that would be 12. That's how many we have in step 1. If I plugged in 2 here, that'd be 4, 8, and 12, 20 plus 4, 24. Yeah, so it looks to be working. You can double check this equation, test it with step 3, test it with step 4, but I think you'll find this is going to work. So let me jot this down here. Y equals 2x squared plus 6x plus 4. All right, wow, that is a tough equation to get to. Now, we can figure out how many in step 43 by just plugging in 43 for x here. So this is going to be 2 times, let's see, x 43 squared is 1849. And then 6 times 43 and plus another 4. Let's see, 6 times 43, 240 plus 8, 258. I think I'm getting, you can double check this, but I think I'm getting 3,960 bricks in step number 43. Double check that for me. I'd love to know if I got that right. How did that go for you? Did you get 60 for step number 4? Did you come up with this crazy difficult equation? Let me know. Thanks, everybody.